Hello everybody. So in this video we will learn about the estimation of iron 2 positive ions using spectrophotometry. In this technique the principle is the absorption spectra, which is shown by the complexes which absorbs UV visible radiation due to the splitting of d orbitals due to the ligand field. So we will talk about all the details which is done in the experimental section for this practical. So initially we will take a look about the apparatus required for this experiment. Here we need an instrument which is UV visible spectrophotometer, some glassware like beakers, burette, also the weighing balance for the accurate preparation of the solutions, some other basic requirement for the experiment. The most important part is the UV visible spectrophotometer for this experiment. So as the procedure, we have to write down all the details for the experiment, such as aim of the experiment, then the apparatus required, the instrument which we are using, here the chemicals for this experiment, the iron solution which will be prepared from Mohr salt, hydroxylamine, hydrochloride, sodium acetate and sulfuric acid. Here the first we will check the balance, check the zero of the balance, so that we can measure the accurate weight of the different samples. Like we are weighing 0.05 gram of Mohr salt, then it should be very accurate. Then we must dissolve this small amount in the small amount of water. Then we'll make it to the final volume so that the standard solution can be made. We must make sure that the solution which we are making should be accurate, because the whole experiment depends upon the accuracy of the solutions which we are making. All the glassware must be clean and ready prior the experiment. Like we have to make different concentration of solutions, so accordingly we have to prepare the glassware. This is the UV visible spectrophotometer we will be using for this experiment. It is a double beam UV visible spectrophotometer in which 1 cuvette will be used for the blank, and the other will be used for the sample. This is the display of the UV visible spectrophotometer. We will be having different analytical methods, and we'll be using photometry, which is first, and the system, there is a zero. The system will firstly we will set the lambda max value, where the complex, the iron 110 phenanthroline complex absorbs, and it is 508, and the system will automatically set blank, and there will be zero absorption initially without any sample. So the different chemicals will be added to the iron solution which we have made, like sodium acetate, 110 phenanthrone. One thing which you all keep in mind that 110 phenanthrone needs to be warmed up a little bit for complete dissolution. This is the cuvette. Here we are adding the iron solution. So absorption for blank is set to 0. This is the first sample where iron 2 positive is there. So you can notice some color in this beaker and some absorbance also 0.049. This is the second concentration. You may notice some color is intensified. This is due to more complex formation in this beaker, and also the absorption increased. This is the third concentration, and it is about 0.16. This is next concentration. So we are gradually increasing the concentration, and the absorption is also increasing. This is the final concentration. Here the absorption is also increased to 0.237. These are, you can notice a gradual intensification of the color and corresponding increase. This is the unknown sample 0.153 which we have made randomly. So we need to find the concentration of this sample from absorbance. Firstly, we will plot a calibration plot. We will plot a curve from the known concentrations. This is the absorption and concentration graph for known concentrations. This is called calibration curve. From this we will draw a straight line, that is fit linear line for this curve. This straight line is the approximate line which is passing through all the dots, and we will write the linear equation for this data, which will give us a value of intercept and slope, from where you may notice the unknown concentration is 0.153, and the graph we plotted is based on these values which we have taken from the experiment. So the different volume of the iron 2 positive ions are converted to their ppm concentration, and there is also the absorption for all of these. As you may also notice that we plotted all the concentrations against the absorption. Again you can see the fit linear graph. So we are again going stepwise so that you can correlate all the points together. This is the linear straight line equation and slope and intercept for this data. Y is equal to a plus bx. Y is the absorption here, and x is the volume of the iron 2 positive ions, which will convert to the concentration. From here you can see for unknown absorption is 0.153, and this is y, and when we put it into this equation, linear equation, then we get the volume of iron 2 positive sample. So the unknown solution contains 1.507 ml of iron 2 positive, and we can find the concentration in ppm from this 1.507 ml volume. It comes up to be 4.822 ppm of iron 2 positive. So as a whole, we discussed about the how we can estimate any unknown concentration of iron 2 positive using their complex formation with 110 phenanthroline, and that complex, when absorbs light in the UV visible region, that can be determined by UV visible spectrophotometer, which gives us a value of absorption corresponding to the concentration. We plot this data of absorption versus concentration, and for it should be linear so that we can use a straight line equation, y is equal to mx plus c, and from the intercept and slope we can find the unknown. We can find the unknown concentration of any sample using its absorption value. I hope you understood the whole experiment. If you have any question, then you may ask in the comment box, and